Hi, this is Mr. Capert. So you've collected data from 16 throws of your catapult. You recorded the mass that you put into the counterweight and then how far it threw. Now it's time to put this into your Excel table that you created a couple, actually months ago. If you've lost your projectile analysis spreadsheet, I put mine up on Canvas and you can just simply download it. Click on this and open it up. You need to enable editing and then start with me from here. So you need to add to this a bit because we have more trials than this. Okay, and then you want to do a border on this. There's going to be a couple of things that change here. The mass, the projectile. Double check this. I have 0.0045. That's in 2018. If I reuse this video, make sure you find out what the mass of the projectile is. But in 2018, that is the mass of the marble. You can click and drag that down. The mass of the counterweight, this is going to be what you recorded in an electronic balance. So for each one of these, it should be that whole counterweight assembly. Everything that hangs from the other end, from the marble, the other end, everything there, plus the mass of the pennies each time. So that should go in here. So you want to enter your data into there. The change in height, yours is going to be different as well. And you don't have to enter it over and over and over. Make sure you converted that to meters. So you can measure it in inches, but go to Google and say 4 inches, 2 meters, and it'll convert it for you. So you want to start entering whatever yours was. It is going to be the same for every throw if you pulled it down the same amount. So you can click and drag. Now once again, use your numbers, not my numbers. I'm going to delete those because I don't want you to accidentally use mine. Now the equation's already in here for all of these to calculate the potential energy, the kinetic energy, and then the velocity and your range. So if you've opened this up, it has all of this stuff in here. Now this is range ideal. Range actual is what you actually found outside. You could put the inches reading in here. To make it easier on you, just put your meters. So this is what it actually fired in meters. This is perfect world computer calculating. This is what you got. Now, if you don't have it in meters, take however many inches you got, put it into Google once again. So if it threw 360 inches, go to Google and say 360 inches into meters. I like to make this smaller. Okay. And then you can do merge and center. Hit it twice. And then this is starting to look a lot better. All borders. Like that. And then your launch angle should be the same every time. Should be 45. If it isn't, put that number and click and drag it down. The equation as well, you need to click and drag that equation so it applies to all cells. Click and drag the equation. Click, make sure you're grabbing that corner. Now to double check this, let's say it's 1 kilogram. It drops 0.04 meters, and notice it calculates potential energy, kinetic energy, how fast it would go in perfect world. Then you put the launch velocity in and it calculates perfect world. And maybe you instead got 10 meters. So you start putting your data in. This will be different. this is different, and this is different. So let me highlight those. This is what you're inputting into here that is different. So fill those in with your data. Let me know if you have any more questions.